Hello, everyone. Today we are continuing with solving ratio and proportions and focusing on things we need to use quadratic formula. So the first thing I want to do is I want you to pause and I want you to simplify these radicals 1 through 4. Try them, come back and check your answers. Okay, so hopefully you remember to simplify a radical. I'm looking for a perfect square factor. So the largest perfect square factor in 72 is 36. So radical 72 can be broken up into radical 36 and radical 2. Square root of 36 is 6, so that's 6 radical 2. So 32 has a perfect square factor of 16. So radical 32 is equal to radical 16 times radical 2. Square root of 16 is 4. So that's 4 radical 2. Number 3, again, I'm looking for the perfect square factor in 48. So that would be radical 16 times radical 3 all over 2. Square root of 16 is 4. So that's 4 radical 3 over 2. I can divide 4 by 2, which is 2 radical 3. Number 4, the largest perfect square factor in 150 is 25. So that's radical 25, radical 6, all over 5. Square root of 25 is 5. So that's 5 radical 6 over 5. 5 divided by 5 is 1. So the answer is just radical 6. Now, here's a reminder, quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. The discriminant is just what's underneath the radical, b squared minus 4ac, and we can use it to tell whether or not an equation is factorable. So how we can use that is if b squared minus 4ac equals a perfect square, then it's factorable. So here I'm going to do, so remember in our quadratic equation, it's ax squared plus bx plus c equals 0. So in example 1, a equals 2, b equals negative 1, and c equals negative 15. So it's going to be negative 1 squared minus 4 times 2 times negative 15. I'm going to do that on my calculator. Make sure that when you square negative 1, it's in parentheses, because negative 1 squared in parentheses is positive 1, and that equals 121. 121 is a perfect square, so that one was factorable. Example 2, again, a equals 3, b equals negative 19, and c equals 10. So it's negative 19 squared minus 4 times 3 times 10, because I'm doing b squared minus 4ac. Do that on my calculator. Again, make sure negative 19's in parentheses. And I get 241. 241 is not a perfect square, so it's not factorable. So I want you to pause and do example 3 and 4. Neither one of these is factorable. Okay, so example 3, I first filled in that a is 1, b is 2, c is negative 1. I substituted those values into the quadratic formula. I simplified what was underneath the radical, which gave me 8. Square root of 8 I can simplify into square root of 4 times square root of 2, which is 2 radical 2. So that gave me negative 2 plus or minus 2 radical 2 over 2. Because I could divide both items in the numerator by 2, I did, which gave me negative 1 plus or minus radical 2. Example 4, first I subtracted 5x from both sides, so it equaled 0. Then my a is 3, b is negative 5, c is negative 1. I substituted into the quadratic formula. I simplified what was underneath my radical, which gave me 37. Square root of 37 cannot be simplified, so my answer is 5 plus or minus the square root of 37 over 6. So now try example 5. Remember that negative 1 multiplies, and put it in simplest radical form. So again, I cross multiplied, got x squared plus 5x equals negative 2. It's quadratic, so I made it equal 0, added 2 to both sides. I then substituted in quadratic formula, got negative 5 plus or minus square root of 17 over 2. Square root of 17 can't be simplified, so that is my answer. If you have any questions, please bring them to class.